Hello, so today's topic is simplifying radicals that have a variable in it. So let's look at this. If we have a variable, the square root of a squared, it means, what this means is what to the second power equals a squared, and the answer is a. So the square root of a squared is a. Just like if we had the square root of 9, we could say that is the square root of 3 squared, and the square root of 3 squared is 3. Or the square root of 16, we could say that's 4 squared, and the square root of 4 squared is 4. Okay? So if we have the square root of a to the third, we have to break that up into two parts. That's a to the second times a to the first. The square root of a squared is a. The square root of a we cannot do. The square root of a to the fourth, break that up into two factors, a squared times a squared. Right? The square root of a to the fourth is the same as the square root of a squared times the square root of a squared. Square root of a squared is a, square root of a squared is a times a squared. Now here's a little shortcut. Okay? On square roots, the index isn't printed, all right? It doesn't show. It's a 2, and we remember that from the first lesson yesterday. Okay, if it's not written, it's a 2. So here's a shortcut you could do. 2 goes into 7. Write a little division problem here. 3 times with 1 left over. That means the answer is a to the third with 1 left over. Let me show you again. Square root of a to the 10th. Divide 2 into 10, and you get 5. That's a to the 5th. If we had the square root of a to the 15th, sorry about that, we would say 2 goes into 15 7 times, and there's 1 left over, and the leftover goes inside a radical sign. Okay? So let's look at a few problems here that combine variables and integers like yesterday. All right, so we are going to factor 12, perfect square 4 times 3, n to the second. We'll break this up into its parts. Square root of 4 is 2. Square root of 3 we can't do. That comes at the end. Square root of n squared is n to the first power. We don't have to write the 1 for the power. Okay, let's look at this guy squeezed over here. I'll write it. Square root of 16x. Can we break this up? Square root of 16 times the square root of x. The square root of 16 is 4. The square root of x we can't do. So this is our answer. Okay. Square root of 18n. So we'll break this up into 18. Separate the two, the integer and the variable. 18 we could say is a perfect square 9 times 2. Variable. The square root of 9, the square root of 2, the square root of n. We can simplify this to 3. These both stay under the radical sign, and it's multiplied, so we just multiply them and write them under the radical sign together. Let's look at this one. We've got a 3 out in front, square root of 48, square root of n squared. Bring down the 3. 48, which perfect square is a factor of 48? Well, 4 goes into 48, so let's rewrite it this way. 4 times 12 times n squared. Can we factor 12 using a perfect square? We can. It's a 4. So again, bring down this. We're going to rename 12. Square root of 12 is a square root of 4 times the square root of 3. Bring down the n squared. Now let's simplify. Got this 3 hanging out in front. The square root of 4 is 2. The square root of 4 is 2. Square root of 3 we can't do. Square root of n squared is n, no radical sign. Everything that's outside is multiplied. So 3 times 2 is 6, times 2 is 12, times n. So 12n radical 3. Okay, let's look at this one. We've got a 3 hanging out in front. We've got the square root of 8 and the square root of b squared. We need to factor 8 if we can using a perfect square. 4 is a perfect square, so 4 times 2, radical 4 times radical 2 is 8, b squared. And now let's simplify. 3, square root of 4 is 2, square root of 2 we can't do, square root of b squared is b. Everything that's outside gets multiplied, everything that's left inside stays there. Okay. We've got a negative in front of this, which is actually a negative 1 times the square root of 36. Okay. Negative 1, the square root of 36 is 6. Square root of k we can't do. Multiply everything outside the radical and whatever is inside the radical. All right, here we've got a 6 out in front. We've got a factor square root of 250 and v to the third. Okay. You might notice there's a bunch of things that multiply to 250, but one of them is 25 times 10. So let's do that. 25 is a perfect square. So we'll call this 25 times 10. That's the square root of 250. Let's factor this to v squared times v to the first. And simplify. 6, square root of 25 is 5, square root of 10 we can't do, square root of v squared is v, square root of v to the first we can't do. What's outside is 6 times 5 times v, or 30v. What's left inside the radicals is 10, radical 10 times radical v, and so we'll just multiply them and put them under one radical sign. Okay. We've got 9 already hanging out here, 144, and square root of b to the fifth. Okay. Square root of 144 is a perfect square, so that's 12. And let's do our little shortcut on this. All right, this is a square root. 2 goes into 5 twice with 1 left over. Multiply everything that's outside the radical signs. So 9 times 12, I think, is 108. B squared. What's left in the radical sign is just the b. Messy b, but a b. Okay, and then let's look at this last problem here. Okay, we have negative 9 hanging out in front. We've got the square root of 72 and the square root of b to the fifth. Oh, we've got that b to the fifth again. So we'll take a shortcut on that. 72 is 9 times 8. So we'll factor that to 9 times 8, both under the square root. Let's take our shortcut here. 2 goes into 5 twice with 1 left over. You look at this, 8 we can still factor again. Perfect square is 4, so 4 times 8. So let's do that. 4 times 2, bring everything else down. All right, negative 9 hanging out in front. Square root of 9 is 3. No radical sign. Square root of 4 is 2. No radical sign. Square root of 2, we can't do. B squared, radical b. We can't do that. Everything outside gets multiplied, so negative 27 times 2 is negative 54, b squared. And what's left inside the radical signs, oops, is 2b. I want to point out one little thing that's a mistake that comes up in these problems. If you have something like the square root of 16, okay, when you find the square root of 16, the answer is just 4. There's no radical sign on it. What I sometimes see people doing is then they do the square root of 4 as 2, but that's not right. Okay? The square root of 16 is 4. There is no square root sign on here, so you don't keep square rooting it. Same thing would happen with like the square root of 81. Square root of 81 is 9, which happens to be a perfect square, but there's no square root sign on it. So this is just your answer. So if you had this problem, 2 radical 16x to the 9th. Okay, we'd break that up into radical 16, radical x to the 9th. Bring down the 2. The square root of 16 is 4, no radical sign on it. And we'll do our little shortcut here. 2 goes into 9 4 times with 1 left over. And then multiply what's outside and what's inside the radical. Okay? So when you find the square root of a number, you write it without a radical sign. Important to remember. All right, get on with your practice. Thanks.